Section 3.1 is about the algebra of functions. Mostly this is just notation. Mathematically, we're not doing anything very challenging. Just to get started, take a look at a function. F of x is x squared plus 3 and g of x is 3x subtract 1. If we add these two functions together, we can combine like terms, and what we get is a new third function. So this section is all about combining two functions together to create a new function. Notation, f plus g of x means f of x plus g of x. F subtract g of x is f of x subtract g of x. So it's pretty intuitive. We can multiply two functions together. We can divide two functions with the qualifier that we can't divide by 0, of course. For example, f of x equals x squared subtract 2. G of x is 4x subtract 3. We can add the two functions together and get a new function. We can subtract the two functions from each other. With subtraction, you want to be careful. Make sure you're distributing the subtraction all the way through, so we'll get a plus 3 here, and then combine like terms to simplify. Okay. F times g of 3, so we've got two different things going on in this example. We're going to multiply the two functions together, but we're also going to evaluate it and let x equal 3. So first I went ahead and did f times g of x. So f of x times g of x, FOILed it out, got a new function, and then I evaluated it, letting x equal 3, simplified, and so our result here, rather than being a new function, is actually a value at the end. And then over here, f over g of negative 3, I did this one a little bit differently. Rather than first dividing the two functions and then evaluating, I evaluated the two functions, f of negative 3 and g of negative 3, and then divided the two functions. So either method works. Okay, here's an application problem. Revenue is price times quantity. So what we're going to do is multiply a price function times a quantity function. And this is an example we used earlier. We're letting the number of units be 1,300 subtract 100 times the price. So first I'm going to rearrange it and find price as a function of x, and then revenue as a function of x. So taking x, the number of units, as a function of price, rearranging, solving for price, I now have price as a function of the number of units. And then since revenue is price times the quantity, here's my price function times my quantity. The number of units is the quantity x. And then we get a new function, the revenue function. And then just take the example a little bit further. The cost to manufacture an object has two components, the fixed and the variable. So the fixed cost would be the $500. It might be things like rent, equipment, etc. that we have to pay the set amount no matter how much we manufacture. Whereas the 3.5x, this would be how much per object we have to put into the object in order to manufacture it. So taking those two functions, combining them, profit is revenue subtract cost. So take our revenue function, subtract our cost function. Again, be careful we're distributing the subtraction through. Combining those, and we get a parabola. So this is profit here. And if we want to maximize profit, what we need to do is find the vertex. So we use our negative b over 2a formula, simplify, and our maximum profit occurs when we're manufacturing and selling 475 objects. Okay, those of you going on to calculus, you're going to see a lot of the difference quotient. The formula for the difference quotient is f of a plus h, subtract f of a over h. I won't go into too many details here, but the idea in calculus is we're trying to find the slope of a curved line. And so, of course, the slope changes constantly, and so we're coming up with a slope formula that's a function rather than a set number. So you don't really need to know that at this point. So for our example, you're going to take f of x as x squared plus x. And first I'm going to find a couple of the pieces. So I'm going to find f of a first, because that's really easy. F of a would just be a squared plus a, whereas f of a plus h, plugging into the f function, a plus h squared plus a plus h. Because our function, f of x, is x squared plus x. So we can multiply it out, simplify. There's not a whole lot of simplifying we can do here, and we've got a function, f of a plus h. So the difference quotient says to take f of a plus h, subtract f of a, and divide it by h. So in red here is my f of a plus h formula, and in green here is my f of a formula. Now notice several of the terms cancel out, and then we can factor out an h, and then cancel the h in the denominator, and we get a new function here. And again, if we're in calculus, we take this, the limit as h approaches 0, and we'd finish it up to get our average rate of change, which is the slope between 2 points. Okay, composition always looks a little strange at first if you haven't seen it before. Just remember, it's not multiplication, it's substitution. And the notation, here's a little funny, f circle g of x is f of g of x. So the idea is we're going to substitute the g function into the f function. So the order is important. If it's f circle g, this one that comes after the circle is a function that gets substituted into the first function, f. Okay, so for our example, f of x is 2x plus 3, g of x is x squared subtract 1. And we're going to both find f circle g of x and g circle f of x. Some students like to call this fog and goff. So fog of x, f of g, we're going to substitute g into the f. So a trick I like to use is first write out the outer function, the f function, just leaving a pair of empty parentheses wherever we had an x in the original function, f of blank equals 2 blank plus 3. And then what we want to find is f of g, so now we can go back, fill in the blanks with the g function, the x squared subtract 1. And then it's just a matter of simplifying and combining like terms to get our new function. Now the order is important. If we take a look at g of f of x, g circle f of x is g of f. So putting the f into the g. So again, g of blank equals blank squared subtract 1, because our g of x formula is x squared subtract 1. And then we can fill in the blanks with the f function, the 2x plus 3. Simplifying, combining. Both of these are parabolas, quadratic functions, but they're not the same function. So the order matters when you're doing the composition. Okay, going back to that profit function example again. So the profit function we came up with, we had x squared over 100, so I went ahead and made it negative 0.01 x squared plus 9.5x subtract 500. This is profit as a function of x, the number of units. So now we're going to go back and find profit as a function of the price. So I already knew that x was 1300 subtract 100p. So what we're going to do is replace the x with the 1300 subtract 100p. And so again, it's a substitution. And you can go ahead and do the simplification. It's not real important.